Let's jump right into this explainer. We open the lid, swipe a finger across a piece of glass, and yank out the power cord literally without a second thought. But underneath that sleek exterior, it's an absolute marvel of modern engineering. We're talking about hidden systems operating with a complexity that honestly rivals our own biological organs. It's wild.
To really understand this technological black box, we're going to look at 4 key areas today. The magic of portability, ACPI as the power maestro, the reversible battery engine, and finally, touchpads and their capacitive sensing magic.
All right, Section 1, the magic of portability. Moving right along to Section 2, ACPI, the power maestro. So, ACPI, or Advanced Configuration and Power Interface. This is essentially the behind-the-scenes hero acting as the ultimate liaison between your operating system and your physical hardware. Back in the day, before ACPI, power management was, well, incredibly clunky. It was mostly handled by the hardware itself. But today, ACPI tables act like these incredibly detailed blueprints. They allow your software to perfectly understand the hardware architecture. It ensures your machine doesn't fry itself or just waste battery for no reason. It literally acts like an internal thermostat, constantly monitoring temps and dynamically adjusting those fan speeds.
Our source material actually uses this perfect metaphor for this. Think of it as a traffic cop, or better yet, a maestro, gracefully conducting this massive startup symphony the second you hit that power button. It decides exactly when specific components wake up, the exact order they wake up in, and when you shut down, it ensures a totally graceful exit. No jarring system crashes, just a smooth, controlled power down.
And ACPI is constantly managing these systems' sleep states. It navigates everything from full, blazing operation at S0 all the way down to a complete lights-out shutdown at S5. All those states in between, S1 through S4, those represent varying levels of sleep and hibernation. By constantly choosing the exact right sleep state, ACPI perfectly balances incredible energy savings with the ability to instantly resume your work. That is exactly what gives you that seamless, instant-on experience we absolutely take for granted now.
But wait, beyond just power, ACPI also flawlessly handles device enumeration. What does that mean? Well, when you plug in a brand new USB drive, ACPI steps in as a virtual tour guide. It instantly gives that new piece of hardware its own unique identity card and introduces it to the device manager. And you don't have to lift a finger or mess with manual configurations. It's this brilliant, high-speed technological handshake happening in literally fractions of a second.
Okay, let's get into Section 3, the reversible battery engine.
Now, unlike those simple disposable alkaline batteries you've got in your TV remote, a laptop battery is a highly complex powerhouse. It actually contains multiple internal cells all packed tightly together, and get this, it has its very own printed circuit board. This board is absolutely vital. Why? Because it precisely manages this massive, constant flow of electrons. It's constantly chatting with that ACPI system we just talked about to monitor battery health and overall charge levels.
So here is the absolute crucial point. This electrochemical engine must be perfectly reversible. When you're unplugged and discharging, an electrochemical oxidation reaction happens right at the negative electrode, while reduction happens at the positive. That sends all those electrons out to power your screen and your processor. But when you plug it back into the wall, that exact flow has to be forced in reverse. Reduction takes place at the negative electrode, oxidation at the positive. If this process isn't perfectly exact, you get this unwanted buildup on the terminals. Over time, that could cause a highly dangerous short circuit. So it's this incredibly delicate, high-stakes chemical dance happening right on your lap.
And finally, Section 4, touchpads and capacitive sensing magic.
Let's trace how this technology evolved. It actually starts way back in 1965 when E.A. Johnson described the very first capacitive touchscreen. But it really wasn't until 1987 that George Gurpfeid invented the modern GlidePoint touchpad right in his basement. He was literally just looking for a way to track fingers without any moving parts. By 1994, boom, this tech debuts in Apple's PowerBook 500, and it completely changed laptop design forever. Fast forward to 2015, and Apple introduces the haptic Force Touch trackpad, entirely eliminating those clunky mechanical buttons.
You probably thought your finger was just a physical pointer, right? Well, actually, to your laptop, your finger is a tiny electrical capacitor disrupting an invisible grid. See, beneath that smooth glass is a microscopic XY grid of transmitting and receiving electrodes creating an electric field. When your conductive finger gets close, it literally shunts some of that electric flux to ground through your own body. The mutual capacitance at that one specific intersection drops by just a tiny, tiny fraction. We're talking like 0.1 to 1 picofarad. Then, an internal analog-to-digital controller instantly detects that drop, converts it, and maps your exact coordinate right on the screen. It's basically magic.
But of course, we don't just point at our screens, we type. We rest the heels of our hands right next to this incredibly sensitive grid. So to stop your resting hand from causing absolute cursor chaos, they use these sophisticated palm rejection algorithms that run constantly in the background. They filter out those unintended contacts using specific size and pressure thresholds. Basically, if a contact shape is too wide or it lacks the dynamic pressure variation of a moving fingertip, the system instantly flags it. It goes, "Oh, that's just a resting palm," and completely ignores it.
Now, interestingly enough, the smooth, premium feel of certain touchpads has very little to do with raw CPU power. A lot of folks notice MacBook trackpads feel incredibly responsive, and that is actually a massive triumph of deep software and hardware integration. They use highly optimized drivers alongside that Force Touch system we mentioned, which actually uses tiny linear resonant actuators to simulate a mechanical click with vibrations. The glass doesn't even move. Windows touchpads, on the other hand, well, their performance varies a lot by manufacturer. But modern Windows laptops rely on Windows Precision drivers to bypass clunky third-party software, which allows for all those advanced multi-finger gestures right at the operating system level.
So, what does this all mean? As these incredible devices increasingly become basically an extension of our own minds, it really makes you wonder, how will these invisible symphonies of power management and capacitive touch evolve next? I mean, we've gone from bulky mechanical trackballs and heavy alkaline batteries to AI-driven palm rejection, solid-state haptics, and these power maestros that balance electron flow on a microscopic scale. The anatomy of the machine is only getting smarter. Thanks for exploring the hidden world of your laptop with me on today's Explainer.
Yeah, Arfa on the night shift.
Survive another round, midnight static on the feed, planting paranoia seed, flip the cameras, check the halls, something glitching on the wall, 6 a.m. that's the goal now, watch me lock the whole place down, circuits burning, eyes like coal, trying to take away my soul, but they can't break my control, yeah, I always make it whole, when the shadows start to creep, all their promises run cheap, I'm the one who owns the night, yeah, own the night.